Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will try to discuss a very important topic, how we can easily monitor the weather and climate data using Google Earth Engine. So basically today's lecture, I will show you that all of those data set which are available for that weather and climate data set, and this type of data set how we can easily use in Google Earth Engine platform, and then different types of weather and climate factor how we can easily analyze this using the Google Earth Engine. So first of all, here you can see the some selected weather and climate data set. So basically all of those data set, mainly it's provided the different types of weather and climate data. So first of all, here you can see this is the reanalysis dataset, weather forecast, and climate projection. In the reanalysis, we can easily get the ECMWF ERA5 daily, as well as we can also get the monthly. We can also get this ER5 land hourly, monthly. We can also get this another dataset NOAACFSR, NCEF, NCR reanalysis data. And mainly for the weather forecast, we can get this type of data in NOAGFS, NOARTMA. We can also get the ECMWF, and climate projection, we can get the CMI P5 next DDP. So in this time, I try to show you that all of those data set, how we can easily use all of those data set and then create the different types of weather and climate data set map, and also make the different types of time series analysis about this map. So let's go about that. So first of all, ERA5 land data set. So first of all, you simply open your code editor. So here I already write about the code for that. So I simply open a new code editor and try to show you all of those things from the beginners level. So first of all, which dataset you want to work, you need to import this dataset. So first of all, I simply search here in this top of the code editor. Simply search here ECMWF. So here I can get all of those dataset about that. You can see the land daily. We can get the ECMWF climate reanalysis dataset. We can get the land monthly aggregated climate reanalysis dataset. We can get the hourly dataset. Okay, you can see land hourly ECM land. So simply click on here. So now we can get all of this information about this dataset. So click on here. So now it opened the new window of this dataset. So basically you can see this is the dataset ERA5 land hourly dataset. And this dataset availability date, you can see we can get the dataset from 1950. Okay, from 2020, we can get the present time. This is the present time we can get this dataset, and this dataset updating daily. Okay, we can get the new dataset for daily. And basically this dataset provide you this type of information you can easily get from here. You can see we can get the dew point temperature. We can get the dew point temperature at the 2 meter. Okay, 2 meters above the surface of the earth. We can get the dew point information. Okay, as well as also you can see temperature. We can get the temperature data of air at the 2 meter above the surface of the land, sea, and inland water. Okay, and also you can see the skin temperature we can also get in here. We also get the soil temperature level 1. So mainly soil temperature of the soil in layer 0 to 7 centimeter. Also get the soil temperature level 2, also 7.3. So it is the different types of range about the soil. Okay, also you can get the lake ice depth. You can see the lake mix layer depth. So lot of information, lot of data set for that. Snow cover, you can see snow cover, snow density, snow depth water equivalent. Also you can see snowfall information. So lot of things we can easily get in here. You can see temperature of the snow layer. So lot of things we can easily get from here. You can see. So you also read about all of this information about the data set. You can see the evaporation from the bare soil. So a lot of things we can get. We can also get the runoff. You can see the lot of things. We can totally precipitation, surface pressure. Okay. Also, you can see the leaf area index, high vegetation. Okay, so that it's provide a lot of information. Okay, we can get the all of this information. And what is the time period? This time period is that from year of 1950 to 2023. Okay, so this is the one kind of data set, ER5 land hourly data set. As well as we can also get the data set. You can see here I already open about the data set. So it is that land hourly data set. Also you can see that it's provide the monthly. Okay, it's provide the monthly aggregated data set. We can get all of the same data set, but in this time we can get the result for the monthly. Okay, suppose you want to need the monthly temperature data, monthly dew temperature data, then you can easily use the data set and you can get the result as a monthly time series. We can get that as a monthly time series. As well as also you can see it's also showing about the monthly by hour. So monthly by hour data set we can also get in here. We can get all of the same band, but in this time it's the monthly by hour data set. Okay, as well as also you can see the another data set about that. Okay, so basically in this time we just talk about this type of data set, ERA5 data set. So basically you can see ERA5, we can get the daily, monthly or hourly. Also you can see the another data set, NOA CFSR. So it also reanalyzes about the data set. You can see it's mainly climate forecast system reanalysis. Okay, so it's mainly provide the climate system reanalysis data set. We can get the data set between the year of 2018 to 2023, between this time period. And basically this using this data we can easily get this type of information. You can see we can easily get the vehicle component of the wind hybrid information. Mainly it is the wind speed. Okay, also you can see the albedo surface, canopy water, evapotranspiration surface, categorical range surface, categorical range surface free. So that it's provided a lot of information. You can see, okay, you can provide this, provide a lot of information we can easily get from here. So you also try to read all of those information, and which data you want to need. We can simply download the data, as well as you can also make the time series chart about this data set. You can see this is another data set about that. So mainly it also provides the about that reanalysis data, surface temperature. We can get only for the surface analysis this data, and it also provide about the year of 1984 to 48 to 2023 present time. And mainly it's provide the data set about that only for the surface air temperature. Okay, surface air temperature we can easily observe from here, and it's the unit is the Kelvin. Okay, so as well as we can also see the another data set for that weather forecasting. So mainly for the weather forecasting we are also use the data set. This data set mainly call that NOAA GFS, mainly global forecasting. You can see this is the global system. We can also use this data set for forecasting the data set for the different types of weather and climate data set we are used for the forecasting. So here you can see the description about that. So it also provides also a lot of information about that. It's the global forecast system, 384-hour predicted atmosphere data. Okay, it predicted 384-hour predicted atmosphere data, and mainly we are predicted this type of information from here. So you can see the temperature 2 meter above on the ground. Also you can see the humidity above the 2 meter ground. Relative humidity we can also get from here. We can also get the component of the wind speed. We can also get from here the 10 meter above ground. Okay, so the total precipitation in the surface we can get the data. Precipitation of water entire atmosphere. Okay, so mainly it's the precipitable water for the entire atmosphere. Suppose you want to identify how much precipitable water for the entire atmosphere, so then you can easily use this, and then you can easily make the time series chart or other things you can easily do. Okay, also you can say the total cloud covered entire the atmosphere. Okay, so this type of information we can easily get, and we can easily use this data set, and then we can easily make the predicted for the 348 hours predicted air data set. We can easily predict it from here. Okay, so this is the, you can see this is the another kind of data set. We are also use the another data set is called that just simply open the data set, then I show you that how we can easily use it. So just simply search here. Suppose I simply search here, the another data set is that ECMWF, mainly it's the CAMS. Okay, so this is the Copernicus Atmosphere Monitoring Service global near time. We are also use this dataset for the forecast for the different types of air and climate dataset. We can easily get from this dataset. So basically, I can see this is the data set. Okay, so just I simply open the data set and show you that all of this information about this data set. We can get the data set between this time period. It's mainly Copernicus Atmosphere Monitoring Service, global near and real time data set. We can easily get from here. And from this data set, we can get the total aerosol optical depth, and we can get the particulate matter in here, PM2. We can get this PM data set also, total column nitrogen dioxide surface, total column sulfur dioxide, okay, total column carbon monoxide, formaldehyde, okay. So this type of gases information you can also get from here. So if you want to make the particulate matter, okay, less than 25 micrometer, the surface, then we can easily use this data set and identify the particulate matter, how much particulate matter in the air. We can easily get this result from this band. Okay, as well as it also provides a lot of information. You can see organic matter aerosol optical depth, sulfate aerosol optical depth. Okay, so you also try to read all of this information, then you can easily identify. You can see the total column ionosphere surface. We can get this data set, nitrogen monoxide surface, okay, hydroperoxide surface, hydroxide radical surface. So a lot of information you can also get from this data set, Copernicus Atmosphere Monitoring Service Global Near Real Time, and this data set between available for this time period. Okay, so this type of air and weather and climate data set we can easily use in Google Earth Engine platform. So now I show you a practical example about this data set, how we can easily use the data set. So basically here you can see here I already import the data set. So mainly it's the hourly ER5 data set. Here I use the ER5 data set. You can see hourly data set. So you can use the same approach for all of those data set. You can see this is the data set about that ER5 hourly data set. So in this time I want to identify for that temperature. Suppose you can see this is the band about that temperature 2 meter, okay, above the temperature of air at 2 meter above the surface of the land, sea, and inland water. What is the condition? Okay, and mainly this 2 meter temperature is calculated by the interpolating between the lowest model level and the earth surface. Okay, so in this time I show you the practical example for the how we can easily monitor the air temperature at the 2 meter above the surface. You can easily apply the same approach for all of those data set and make the analysis. So here you can see there is a lot of data set. I already show you that you can apply the same approach all time. When you want to, suppose in this time you want to work with the dew point, so you want to simply select the dew point and work with that. Okay, just apply the same approach. So in this time, first of all, what I need, just I simply copy this art snippet. So basically this is my data set. Simply copy and then paste in here. Okay, just I simply paste in here. After that, you can simply filter your specific time period. Suppose in this time I need the data set for that time period. So you can see for the year of 2020, 70712 second. Okay, 2nd August. Okay, 1st August to 2nd. Between this time period, I want to identify about that temperature. What is the condition about the temperature? So finally, I simply select my band about that temperature 2 meter. So this is my band name. Select this band. Okay, so this is my data set. I simply select my data set. So now I just show the result. You can see here. Just show the map data layer, and then we can get the result. What is the condition about the temperature from ground to the 2 meter above? We can get the temperature, and this unit is the Kelvin. Okay, so if you want to check the result, suppose I click on here. Here I can get the result, this type of result. You can say I can get the result is that suppose 287 Kelvin, not degree Celsius. You can easily convert this unit as a degree Celsius. So what we can do, just I simply add a function. Just simply use here the map function and convert it from Kelvin to degree Celsius. Just simply use here the function and then take element name as the image and then put your argument. In this time my argument is that I want to just convert this image as a Kelvin to degree Celsius. So just simply subtract the value 273.15, then it automatically converted. Okay, So now if you want to check the click to the run, in this time I can get this result look like that. I can get the map look like that. I need to change the mean and max value about that. So simply click on here, and then I simply customize a 98%. So now it provide, you can see it provide the mean and max value about that. Negative 9 this value. I simply copy that and paste here in the mean value, mainly the degree Celsius. Okay, and if we can also get the maximum value, it's that mainly for that degree Celsius also. So just I simply put this result. So now click to the run. In this time I can get the proper map in degree Celsius. So now I can say I can get this proper map. If you want to check the value, suppose I simply click on here. Suppose I click on here. So now I can get this result is the 39 degrees Celsius. Okay, in the air temperature at the 2 meter above from the ground. Okay, suppose you can easily select in here, we can get this result about that. Okay, so in this time I can take only for the one. Suppose you want to make the 1 month, just I simply put here the change the time, suppose 30, and click the run. In this time I can get the result for that 1 month. Okay, the whole month of August, what is the condition about that. Okay, you can see in this time it's loaded. We can get the result look like that. For the whole world, what is the condition of the air temperature from the 2 meter above from the ground or surface, we can get the result. Suppose click on here. So now I can get this temperature. You can see for this time how many degrees Celsius, 38 degrees Celsius, we can get this result. So now if you want, you can also make the time series chart. Suppose you want to make the time series chart and check what is the condition, when it will be high, when it will be low, we can check it. So for that, very easy, just you can simply, suppose this is my area of interest. So for this point, I want to identify what is the condition of the air temperature from 2 meter height from the ground. I want to identify using the time series chart. It is very easy. We can easily make the time series chart. For that, I simply use a function UI dot chart dot image dot freeze and put all of those. First of all, image collection. So in this time, this is my image collection data set. I simply copy and paste. My region is that mainly in this time geometry. So put here the geometry. And then reducer, I want to use at that. Suppose I want to calculate it, the average result. So EE dot reducer dot mean. In this time, a scale about this data set. So here you can get the scale. You can see this is the scale is that hourly data set. This scale is that we can get this scale is that this is the scale about that. Simply copy the value about that for a scale and then paste here. And then X property. So mainly X property is that I simply mention about that default as a system time start. So use at the system time. And then I simply print that result. So just simply print, use the print function. And then click to the run. In this time, it create the time series chart for the month of August. What is the condition about that? Okay, now click to the run. Okay, now it's generating the chart. And from the chart, we can easily get this result about that. Let me check. Okay. Okay, so now we can get the result in here, but this unit show as a Kelvin. Okay, so further we have also need to convert this unit. Okay, suppose you want to show the degree Celsius. For that, you want to make the time series chart from as a degree Celsius. Or I put this variable name such as a suppose degree Celsius. Then call my data set. Okay, okay, I understand. Okay, so in this time we are just mistaken here. This mistake is that we have to apply these things from system instance. So just put here that copy properties from copy properties is image. Put here that system time start from system time and so now click to the run. I hope now we can get the better result and degree Celsius. Okay, so like I said, I can get the result in degree Celsius. Okay, so just simply click on here. I can get the chart look like that. Okay, you can say I can get the chart look like that month, or we can get this result, and from here we can easily get the result in degree Celsius for the above the 2 meter height from the ground. What is the condition about the temperature? So download it from here. Download the CSV. So now we can get all of those data in Excel file or CSV file for the temperature. You can say I can get the result in here. Okay. So using the same approach, you can also put here the for the other data set which are available. You can see the Copernicus Atmosphere Monitoring Service data set. This is a daily data set. We can also use here the monthly data set. Also, you can use here the monthly hour by day data set. We can also use this data set for that climate forecast system reanalysis. Also, you can see this is another kind of data set. So all of those data set has lot of band. You can see that the lot of band about that. Which band you want to need, you can simply select that and then you can easily make this map. Suppose in this time you want to make the map for the specific shape file or a specific boundary. Suppose you need this map for that Saudi Arabia region. Okay, so what you can do, just simply import the Saudi Arabia boundary shape file. Suppose you can simply import the Saudi Arabia boundary shape file and then work with that. Suppose I can simply import the Saudi Arabia boundary shape file and you put this name as a ROI, and now I want to make this map for this Saudi Arabia region. So for that, what can I do? Just I simply use here. You can see, yeah. So this is my data set. I simply use here that mean function. I reduce this image, and this image just clip with my boundary. So clip with my boundary is that ROI. Then click run. In this time, I can get the result only for the Saudi Arabia region. What is the condition of air temperature from 2 meter height from the ground in Saudi Arabia? We can get the image or we can get the map about that. So now I can get the air temperature map of Saudi Arabia region. It loaded. Okay. So now we can get this type of map. It's identify about that air temperature 2 meter height from the ground. Okay. If you want to check where is high, so mainly it's the high part. So simply click on here. Here we can get the result. How many? 38 degrees Celsius. Okay. And when we click on here, so then we can get the result. You can see low 24 degrees Celsius. Okay. So basically it's the vegetation about that and the pressure about that. So click on here. I can get the result. You can see. You can get the high temperature from the 2 meter above. So air temperature is the high 37 degrees Celsius. Okay. So this type of things we can easily do, as well as if you want, you can also download this tip image from here and use it in ArcMap software for make the maps. Okay. So basically all of those data set which I already show you that you can easily apply the same approach and do for the different types of weather and climate data analysis using the Google Earth Engine platform. If you have any question or any doubt, you can just contact with me. And finally, I also give you an announcement for our upcoming online training program, which will be start on the 10th October. Okay. And you can see basically this online training program, we are just mainly focused the beginners who don't have any knowledge in the programming or who don't have any knowledge in the coding. Okay. After completing this online training program, you are able to do any types of remote sensing analysis very quickly and efficiently using the Google Earth Engine platform. So here you can see basically for the course syllabus. So basically you can see the course syllabus totally live training program. Okay. So anyone can easily join this live trading program and then easily complete all of those things. So basically you can see the first day. So mainly first day we try to discuss about the Google Earth Engine, then how to use the Google Earth Engine for JavaScript and Python API. As the beginners, if you have no knowledge about the coding, then we also try to completing the coding section. Okay, so from the JavaScript and Python, all of the syntax you can complete, and then we talk about the client and server object on Google Earth Engine. Okay, and how we can get the server to execute our code, then how we can easily importing the raster and vector data, local storage, and Google Earth Engine data set, how we can easily filtering the attribute table. Okay, then we come talk about the second day. Second, we try to mainly discuss about the how we can easily filtering and displaying the satellite images, mainly Landsat, Sentinel, or MODIS. Then how we can easily create the composite, how we can easily use the different types of band combination, how we can easily export the satellite imagery, mainly Landsat and Sentinel and MODIS data set, how we can easily import, filter, reduce, clip, and display the raster data in Google Earth Engine, how to make the time series chart using for NDVI or NDWI or any other types of indices, how we can easily create, and you using the Google Earth Engine ready-made dataset, how to export any shape file. We also try to discuss about that. And third, we just discuss about that calculating any indices from the satellite images using the Landsat and Sentinel imagery. So filtering and displaying the satellite image, mainly Sentinel-2, and monitor the NDWI and NDVI. Extract the water body using the thresholding technique. Okay, so NDVI and NDWI is savvy. All indices how can we create in using the Landsat and Sentinel imagery. How to export any shape file. How to add the gradient legend. How to calculate NDWI. Okay, we also discuss about the how to remove the cloud from and haze from the satellite imagery. Lot of things here. You can see here I mentioned all of those things. You try to check about that, all of those course content or course syllabus. And you can see if you want to join this online training program, you are also get the some benefit, such as you can get the e-certificate after submitting all of those assignment. You can get the materials, all of those slide PDF. You can get all of those practice code, as well as you can also get the recorded classes. If you miss any class, then you can easily cover it using the recorded video classes. And you can also get the lifetime teaching support. Okay, suppose after completing the 7 days online training program, when you face any problem regarding any issue in Google Earth Engine platform, you can get the free support for any time, and it's continue from the lifetime. When you face any problem, you can get the supported. There is no problem. Okay, so our training will be start from that 10 November. Okay, and if you want to join this, you can simply contact with this WhatsApp number, as well as you can also contact with this email. Okay, and I add all of this information in the video description. You can simply check it, and then you can simply contact with this WhatsApp number and contact with this email. Okay, for registration. Okay, so today is no more. Stay safe, stay happy. Thank you for watching that.